So welcome in this session. We are going to prove the first triple product for vectors. So this is a problem. So given vector A is given by A1I plus A2J plus A3K, vector B, B1I plus B2J plus B3K, and C, C1I plus C2J plus C3K, show that A dot B cross C is nothing but the determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. So this is a problem. So to solve this, we'll start by defining the cross product of B and C. So the proof we start with B cross C. So by definition, B cross C will be given by the determinant I, J, K, B1, B2, B3, C1, C2, C3. And we use cofactor expansion by knowing that this is positive, this is negative, this is positive. So I will have I, close this will have B1, B2, B3, C2, C3, minus J, B1, C1, B3, C3, plus K, close this and close this, we'll have B1, B2, C1, C2. So that we'll have this determinant will be B2, C3 minus B3, C2, I minus B1, C3 minus B3, C1, J plus B1, C2 minus B2, C1. Okay. So therefore, finally now we define A dot B cross C, which will be A1I plus A2J plus A3K dot, so B2 C3 minus B3 C2 I. So this one can be written as plus. Now I start by writing this term, B3 C1. This is minus B1 C3 J, and then plus B1 C2 minus B2 C1 K. And then dot product to simply get the sum of product of I components, and then J components, and then K components. So this will give us A dot B for C equals to A1. So we multiply by this, B2 C3 minus B3 C2, and then plus A2 multiplied by B3 C1 minus B1 C3 plus A3 into B1 C2 minus B2 C1. And this will give us when you open, or even without opening, that's actually the structure. This can be written as A1 B2 C3 minus B3 C2 minus A2, and then I have B1 C3 minus B3 C1 plus A3 A3 B1 C2 minus B2 C1. And you see this is nothing but the determinant A1, A2, A3, and then B1, B2, B3, C1, C2, C3. So that's the result for that given problem. Also, you can see this, close this, the sign of this plus, so B2 C3 minus B3 C2. So this is what you have here. Sign of this one is negative, so close this and close this. We have B1 C3 and then C1 B3. And then the sign of this one, remember this is A3, not B3. Should be A3. This should be A3. You close this and this is positive, so B1 C2, B2 C1, and then at the end. So therefore, this is a proof of that given problem. So thank you.